Okay, so now we are going to talk about pendulums, and I have drawn a pendulum up here, and it's just going to go back and forth on this, hence the arrows. And you can use one of the two formulas up here, and you choose which formula to use depending on what information's given. So you would use this one to find the period, which the period is the time to complete one period. So one motion, if it started up here, would be like 1, 2. And so that would be the period. And you would measure that in seconds. And then you have mass over the spring constant. And the spring constant is the constant number of resistance in the swing. So like it would be the weight. The mass is the weight of the ball, and you would measure that in kilograms. And then this formula to find for a simple harmonic is the period equals 2 pi the square root of the length. So the length of the string or the chain or whatever you're using over gravity. So, and the gravity is the constant, 9.81. So, the example I chose was if a kid was swinging on a swing and the chain was 3 meters, then you'd use that one for simple harmonics. And you would plug in 3 and 9.81 for the length and gravity. And so you'd get 3.47 seconds for the period. So in order to go back and forth, it would take 3.47 seconds. Now, if you had the weight of the kid, which I used the 65 pounds again, so it equaled 29.48 kilograms. And I said a period happened in 1 second. So you'd plug in 1 for the t, and then 2 pi would stay the same. And you'd have square root of 29.48 over the spring constant. And after doing algebra, you'd get 1.49 newtons per meter as your spring constant. And so, in other words, we can also talk about frequency, and it's how often the swinging occurs. So how often it might be on the left side or how often it's going to be on the right side. It's just how often the period occurs. And we can also talk about amplitude in this instance with knowing that amplitude is the maximum displacement from equilibrium. You're at